Subscribe to our channel and press the bell icon to never miss any update. From Gradeup.
Hello everyone, this is Swarid Dwivedi, and as we were discussing about JEE Mains 2017 chemistry question paper, in the last screencast we have already discussed question number 1 to question number 10th, and in this screencast video will be particularly discussing question number 11 to question number 20th. So as I have told, the difficulty level of in question number 1 to question number 10 was like fairly easy questions were there. In this screencast, the questions are more on like a moderate difficulty level, because a lot of questions are from inorganic chemistry, and some qualitative analysis questions are there, some basic physical chemistry questions are there. So they are not tough nor easy, so a couple of concepts you need to work out and you'll be able to solve these questions. So I'll be targeting these questions in this screencast videos 11 to 20th, and so yeah, let's start our discussion. Yeah, so in the first question, it tells us that both lithium and magnesium display several similar properties due to diagonal relationship, which is a known phenomena. So what is diagonal relationship? Basically, in the periodic table, you have something like this, and in the second group, you have magnesium, so they are diagonally placed in the periodic table. So according to the diagonal relationship, it says us that a lot of properties of these two elements will be similar. All right, so however, which of the following is incorrect? So there are some properties which tells you about lithium and magnesium, and it has been asked that which of the following properties are not similar for these two. They both form nitrites. This is true. They both form nitrates of both Li and Mg yields NO2 and O2 on heating. That is also correct. They both form basic carbonates. That is also correct. The that is actually not correct. I'll tell you why. They don't form basic carbonates, both of them. Both of them form soluble bicarbonates. That is correct. In fact, all the bicarbonates are soluble whenever they are formed, so you should know about that. So many of the bicarbonates are in liquid form, some are in solid form, but the carbonates are basically water soluble. Their solubility can be compared, but they are water soluble. So both forms basic carbonates. That is not true. In fact, Li doesn't form a basic carbonate, but magnesium in fact forms a basic carbonate. How does it do that? So whenever you put magnesium inside the basic solution, or inside the water, sorry, not basic solution, inside the water, so it forms something which is like MgCO3 dot MgOH whole twice. So they can be in like some particular amount X and Y. But in fact, if you know, this X is actually 4 in case of magnesium, and Y is 1. So 4 MgCO3 dot MgOH whole twice dot 5H2O. So this is a basic, kind of carbonates which is formed on putting it into the water. So yep. So magnesium actually forms a basic carbonate, but the lithium does not. So this option is incorrect, means hence it is correct, because the question asks us for the incorrect option. Which of the following species is not paramagnetic? Okay, so for paramagnetism, finding out what is paramagnetism and what is a paramagnetic species and a diamagnetic species, you just need to know the electronic configuration according to the molecular orbital theory, and you need to know whether there is a single free electron in some orbit or not. If there is a single free electron in an orbit, the species is known as paramagnetic. So among these options, CO is a paramagnetic compound. Why so? When you try to look at the molecular orbital configuration of CO, you see you have 2s electrons, right, present in both carbon and oxygen. Then when you talk about 2p electron, carbon has 4 of them. No, carbon has actually 2 of them, and oxygen has 4 of them. So when you place it, and in this electronic configuration we have 2 electrons in these two, and when you place them, then what you do here is you fill first this pi orbitals, right? 2 pi. In this configuration you fill the pi orbitals first, and then you fill the sigma orbitals. Then there will be pi star orbitals you fill, and then you fill sort of sigma star orbitals. So here when you fill these 6 electrons, you'll fill first in these 3 orbitals, these 6 electrons. So every orbital will consume a couple of electrons. So there is no single free electron in this configuration of CO. So when there is no single electron, that means the species is diamagnetic. So CO here is a diamagnetic species. So hence the option is correct, because it has been asked which of these following species is not a paramagnetic species, right? Okay, moving on to the 13th question. Which of the following reactions is an example of a redox reaction? So this is a fairly simple question. So you just need to know, in a redox reaction, some species particularly oxidize, right, and the other species just reduce. Alright, so the oxidation and reduction takes place in a redox reaction. That's why the name is there, reduction oxidation, redox reaction. Alright, so we just need to identify whether there is some species which is going through oxidation and reduction in the following reaction. So as you can see here the xenon, okay, it's +6 oxidation state, and it maintains here. Fluorine -1 maintains here, oxygen maintains the oxidation state, and hydrogen as well. Here +6 oxidation state, again -4 -2 +6 oxidation state here again, and it doesn't change the oxidation state. And in XeF4 going into XeF6, is there oxidation state change? Yep, it is going from +4 to +6 here. Alright, and oxygen which is here is eventually changing its oxidation state as well, right? So it's from +1, alright, not it's from half, it's going into 0. So it's actually a oxidation / reduction reaction, and it is called as a redox reaction. And in the 6th option also you can see here in XeF. In the 4th reaction you can see here, okay, so this is seeming kind of confusing here. So this is not plus PF6 minus, the plus sign is on the coordination sphere. Okay, so the plus sign is on the so this is a coordination compound actually. So the plus sign is on the coordination sphere. Alright, so the plus sign is eventually on the coordination sphere, and this is PF6 negative, right? So here also you can see very easily that the oxidation state of Xe remains from +2 to +2, and of all the other species as well. So this is also not a redox reaction, because nothing is going under oxidation and reduction. So only there is reaction the 3rd reaction, in which the xenon is changing its oxidation state, and hence it is a redox reaction. Alright, okay. So now this is a basic question from your environmental chemistry concepts, and you just need to either either logically remember the facts or just mug it up or something. But every once now and then they are asking a question on environmental chemistry, which is very necessary as well, because being an engineer, being a scientist, you need to know about what are the substances around you, because there is a lot of effort over the green chemistry, the environmental chemistry, and how to keep your environment clean, and you should know about these facts. So a water sample has ppm level concentration of the following anions. So so there is basically a water sample, and they have just taken the measurements of this sample, and they have found that the concentration of fluoride ion in this sample is 10 ppm. Concentration of sulfate ion is 100 ppm, and concentration of nitrate ion is found to be 50 ppm. So what ions and anions make this water sample unsuitable for drinking? So for drinking purpose, you know that like the sulfate level should be less than 500 ppm, nitrate level should be less than 50 ppm, and fluoride ion level should be less than 2 ppm, right? So but here in this, okay, this is fairly like equal, so that's fine, but the fluoride ion concentration here is way above 2 ppm, which is not desired. So what fluoride does, it try to have your deplete your teeth and have some deposition on it, so that is actually not desirable for us in drinking purpose. So the rest everything is fine, right? It's either in the limit or it's way below the limit. So the fluoride ion is making the water not suitable for drinking purpose. All right, okay. So now the group having in the question number 15th, obviously the group having isoelectronic species is, what are isoelectronic species? Which are having the same number of electrons in them, or the electronic configuration is same. So you have let's say, because in all of the options you can see that F negative is present, so let's take it as a base. So F negative is there. So F negative, so in the periodic table you have N, O and F. So if F negative means one electron more than F was having, so oxygen has one electron less than fluorine, and if F has a minus charge, so oxygen should have two negative electron just to be equivalent to fluorine negative ion, so to have the same electronic configuration. And sodium is present here at the at the subsequent row. So Na should have a positive charge in order to have the same electronic configuration as F negative. For Na to have a same electronic configuration as of F, it needs to lose 2 electron, but we have F negative, so Na should lose 1 electron to be equivalent to fluorine, and Mg, which comes afterwards after to Na, should lose subsequently 2 electrons just to be of the same electronic configuration as of F negative. So Na plus, Mg2 plus, F negative and O2 negative. So Na plus, Mg2 plus, F negative and O2 negative all are having the same electronic configuration. That's fine. All right. So the 16th question, the products obtained when chlorine gas react with cold dilute aqueous NaOH. So this is a very basic reaction from your inorganic chemistry, and when a chlorine gas reacts with cold dilute OH minus or NaOH, which is equivalent, then what happens? You get a Cl negative ion and you get a ClO negative ion. What happens? Obviously these ion will get attached to Na plus or not, depends, but chlorine breaks down to Cl negative and ClO negative ion. All right, so basically it's a heterolytic fission of the Cl bond, right? So you get a Cl plus and you get a Cl negative. Cl negative remains the same. Cl plus gets attached to the O2 negative and forms as ClO negative. All right. So yeah, so this is pretty much what happens when you have chlorine gas inside a cold dilute aqueous solution. So okay, so here the option number A is correct. moving on to the 17th question. In the following reactions, Z and O is respectively acting as A or N. Alright, so it's asking that there are a couple of reactions. So Z and O acts as what? In the first reaction, Z and O acts as what? And in the second reaction, Z and O acts as what? So either Z and O acts as an acid or Z and O acts as a base. What's going on? Alright, so if you can, either you can see the oxidation states as well. Alright, or you can just compare the reaction, what's happening here. So in the first reaction, since this compound is acting like a base, so this acts like an acid, and here the CO2 acts like an acid and ZNO acts like a base, alright, to form the subsequent compounds. Okay, so in the first, obviously the sodium oxide will act as a base and carbon dioxide acts as an acid. This thing you know. Okay, so if this is acting like a base and this is acting like an acid, so ZNO acts like a acid here and acts like a base here. And you know that the ZNO is an amphoteric compound. You read about it. So this is a fairly simple question, I must say, because from your common sense, from looking the compound, how they look also, you can judge it. Okay, so in the first reaction it acts as an acid, and in the second reaction it acts as an base. So remember, ZNO is an amphoteric compound. Alright, okay, so let's move on. So now in the 18th question, a sodium salt of an organic acid produces X, or of an organic acid, X produces effervescence with concentrated H2SO4. X react with the, reacting with the reacting with concentrated H2SO4, it should give some effervescence, means some bubbling should be there, some gas should evolve. That's what we mean by effervescence. Alright, so an X, the same compound X reacts with aqueous CaCl2, right? With aqueous CaCl2, it gives a white precipitate. So you should get a white precipitate, and this precipitate, whatever this precipitate will be there, this white precipitate should decolorize KMNO4, acidic solution of KMNO4, right? So let's take an acid. So it should decolorize it. So let's see. So here I'm going to tell you about the correct solution, because this is a qualitative analysis question and you should know about it. So here your correct option is Na2C2O4. So when you react with Na2C2O4 with concentrated H2SO4, you get Na2SO4, and then you get CO as well as you get CO2, and you get some H2O. Alright, I'm not very much concentrated on balancing the reactions, because balancing does not matter here, but I guess the first reaction is balanced as much as I can see right now. But then again, so out of these, so now again if I react this, this organic acid, right, with aqueous solution of acidified aqueous solution of CaCl2, I should get a white precipitate. So here I do get a white precipitate. So it's just like the like a acid base reaction. So what you get here, you get CaC2O4, which precipitates eventually, and then you get NaCl, because NaCl is what generally forms. That's a nice compound you are getting. Alright, so now this white precipitate of CaC2O4. Okay, so when you have the reaction of this CaC2O4 with KMNO4 in presence of an acid, you get K2SO4. Alright, and then you get MnSO4 as well, which is eventually now colorless. So now when you have some color, and now this color was because of Mn, right? And now this is becoming colorless. Okay, and then you get some CO2 as well, right? In the end you get some CO2 as well. So eventually what you needed to know, whether it decolorizes this solution or not. Yep, it decolorizes the KMnO4 solution. Alright, and rest the other options will fail at certain points, but you need to know these reactions from your qualitative analysis concepts. Okay, so this was the 18th question, and the correct answer for this question is B part Na2C2O4. Alright, now the 19th question. The most abundant element by mass in the body of a healthy, so first let me tell you about this question. It looks a big question, it looks you need to do a lot of calculation in this, but nothing is required at all. It's a very simple question, so let me tell you about it. So the most abundant element by the mass in body of a healthy human adult are, okay, so most abundant are, I don't know. Okay, so oxygen 61.4%, carbon 22.9%, hydrogen 10%, nitrogen 2.6%. The weight which a 70 kg person, maybe in a nice body shape, would gain if all atoms are replaced by, alright, so there's a mistake here, all atoms are replaced by H2, I guess. Yep, H2, or I would say the deuterium. So what is happening here, the hydrogen which is present in 10%, right, is being replaced by deuterium, right, which is eventually H2, whose weight is just double of hydrogen. All right, so so now it has been asked that the person would gain how much weight. So let me see. So when all the carbon, the hydrogen, the nitrogen and oxygen were present inside the body, okay, so this is a body, let's say, so he was weighing some 75 kg. Now what I'm doing here is I'm keeping the carbon, the nitrogen and oxygen fixed. I'm replacing this hydrogen, right, with deuterium. Okay, so whatever the hydrogen was there is replaced by deuterium. So what will be the mass of this person now? So you know that the 10% of body mass was hydrogen. 10% of body mass, not moles. Body mass was hydrogen. So 75 kg, and 10% of 75 kg will be 7.5 kg, right? 7.5 kg of the mass was made by hydrogen. And now I am replacing this hydrogen with deuterium. So now deuterium weighs just double as hydrogen. So now this person, whatever mass is being constituted by this part, will not be 7.5 kg, will be 15 kg, because deuterium just weighs double. So if changing hydrogen to deuterium, you are going from 7.5 kg to 15 kg. So now the weight of the person will be 90 kg. And what is the increase in weight? What is the, sorry, not 90 kg, sorry. The weight will be now 82.5 kg, right? Because you know you are going from, you had that 7.5 here, you are adding another 7.5. So the increase in weight will be 7.5 kg. So here the option A is correct. Okay, very fairly simple question. Maybe seeing the language of the question you might get confused for a while, but that's a fairly simple question. It doesn't require any of the chemical engineering concepts. It's just a basic intuition, or you can say a aptitude question as well. Okay, so the last question for this screencast is on treatment of 100 ml of 0.1 molar solution of COCl3.6H2O. So now, so this I guess is or something, I don't know. Okay, so on treatment of 100 ml of 0.1 molar solution, so of COCl3.6H2O with excess AgNO3 ions are precipitated. All right, so now it has been asked the complex is. Okay, so you know this thing that if you are getting a complex, okay, and let's first talk about how many moles of COCl3.6H2O were there. So we have given the volume, we have given the molarity. So molarity is equals to number of moles divided by the volume, hence implies the number of moles will be molarity into volume, which will be 0.1 times 10 to the power minus 1 liter. So which means 0.01 moles were there. And now it tells that these 0.01 moles are treated with excess AgNO3. So means are treated with AgNO3. Now 1.2 into 10 to the power 22 ions are precipitated. Which will be those ions? So Ag will take Cl and precipitates. Ag takes a Cl and precipitates. How many ions are going to be precipitated? 1.2 into 10 to the power 22. So let's say the moles of ions precipitated, right? The moles of ions precipitated will be the number precipitated divided by Avogadro number, 6.2 into 10 to the power 23. So if you solve this comes fairly close to 0.02. So for 0.0 moles, right, of this species, 0.02 moles are being precipitated. So just twice the number is being precipitated. So every 1 mole of this compound, 2 moles of chlorine are getting extracted. So it means out of these 3 chlorines, 2 chlorines will be going to this Ag and getting precipitated. So only 1 chlorine will remain directly attached to CO inside the coordination sphere. Okay, so let's see out of these atoms. Okay, out of these options, 1 chlorine is attached to cobalt in this B part. Rest every other part there is no chlorine, which is not true. There are 2 chlorines, which is not true. All 3 chlorines are remained attached to CO, which is also not true, because if all 3 will be remained attached to CO, nothing will precipitate. All right, so if just the double of moles of chlorine are getting precipitated, so it means for every 1 molecule of this compound, 2 molecules of chlorine are going out, getting attached with Ag and getting precipitated, right? So in this case, the B option is correct because it's the correct stoichiometry. All right, so this is screencast. Obviously, we have discussed question number 11 to question number 20th, and stay connected for the last screencast to get the solution for question number 21st to question number 30th. If you haven't downloaded the Gradeup app, which should be rare, you go to Google Play, App Store, download the Gradeup app. You can get new tests every day, complete notes of all the chapters along with the important notes and the revision and the formula base and everything is available there. And if you have any doubt, you can always just it's very easy, you can post a doubt, you can discuss about your doubt with your fellow students. Everybody is responsive there, even our experts are on the panel. You post a doubt, we see the doubt, we reply to you on the same time, and yes, you can solve your problem because you are left with very less time for your exams. So I really recommend you to go and download the app. This is the #1 app for your exam preparation. So this is Sorry Dwivedi signing off for this video. Let's catch up in the next video to just summarize this JEE 2017 question paper. All right, thank you.